Welcome to Metal Casting Lecture Series by Professor Joyjeet Ghose. This is the fourth lecture of a series of lectures. This lecture will be on sand casting pattern allowances. He will be discussing about shrinkage allowance, draft allowance, machining allowance, camber allowance and wrapping allowance. The method of calculation of these allowances is also explained with examples. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture 4 on metal casting. This is one of the lectures of a series of lectures on metal casting that I'll be delivering. In this lecture, we'll be discussing about sand casting pattern making allowances. So in this lecture, we'll discuss what are the different types of allowances that are added or subtracted from the pattern, and we'll solve some numericals based on pattern making allowances of pattern design. So let's start. Pattern in my earlier lectures I have defined as an approximate duplicate of the final casting. Now why it is called an approximate? Because it has several allowances attached to it plus the core prints. So you can say the pattern of exact dimension of the final casting plus the core prints attached to it plus the allowances makes the pattern dimension. So what are these allowances? That allowances we'll be discussing in today's lecture. So start with first allowance, that is the shrinkage allowance. Now what is shrinkage allowance? You see, when the liquid metal is poured in a cavity, in the mold cavity, then the liquid metal, the temperature decreases and it reaches a solidus temperature. That means at that temperature it solidifies. Now when it starts to solidify, it shrinks. Such shrinkage is called liquid shrinkage. Now the liquid shrinkage is compensated by the liquid metal in the riser. But when the liquid metal solidifies, it cools down. When it cools down, it also shrinks. That shrinkage is called solid shrinkage. Now solid shrinkage is compensated by shrinkage allowances. Now what is this shrinkage allowance? That means we'll make the, when the solid metal inside the mold solidifies, it shrinks. Now when it shrinks, it becomes smaller than the mold cavity. That we don't want. So what we have to do is that we have to make the mold cavity slightly bigger, so that when it cools down, it comes to the required size of the final casting. Now there is a problem associated here, because different metals have different shrinkage allowances. Because of the properties of the metal, different metal will shrink at a different rate and different amount. So therefore, there are certain handbooks available, charts available in handbooks, metal casting handbooks, where it is given that this much allowances you should keep, so that to the pattern you should keep, so that when the solid shrinkage occurs, it shrinks and comes to your required size. Now these tables are indicative only, and you have to carry out trials, actual trials, and come to a conclusion for your casting design. I have always said casting is a trial and error process. So in my next slide, I'll show you this table I have taken from P&Rao book. You can see for different material like clay cast iron up to 600 mm, this much allowances, shrinkage allowances to be added. This is 10.5 mm per meter. So if the dimension is 600 mm or let's say 500 mm, so 500 plus 0.0105 into 500. So that much allowances will be given per mm. So 0.0105 into 500. So likewise, you have to give the allowances for different metals. So this table will be requiring while solving the problems. So please make a note of this table and then it will be required while we solve the particular problems. Okay, the next allowance is draft allowance. Draft allowances are provided to a pattern, particularly to surface which are perpendicular to the direction of withdrawal. So the parallel to the direction of withdrawal and perpendicular to the parting line. So parting line is that line which separates the cope and the track. The upper half is called the cope, upper half of the flask, the pattern, the mold is called the cope, and the lower half is called the drag. The line separating or surface separating that is called the parting line or parting surface. Now, any surface of the mold which is perpendicular to the parting surface and parallel to the direction of withdrawal, now the problem arises during the withdrawal of the pattern from those surfaces, particularly in the corners. When you tend to remove because of the friction, because this sides, perpendicular surface sides of the pattern touches the perpendicular sides of the mold, and as you drag there will be friction, and because of this friction the corners may break and it is difficult to take out. So what we do is that we make it slightly taper, and that allowance is called the draft allowance. Now what happens if we make it taper? If we make it taper, you can see in the figure on the right hand side, if you make it taper with slight force, we can lift up. Once it lifts up, the pattern becomes free from all sides. Even if it is slightly up, you can see it is free from here. So it becomes free from all sides and you can take it out easily without spoiling the mold. Now after we have finished the casting, we have to machine this and bring it to required shape. For better casting, we have to make it slightly taper. Now the question is how much taper? Now, how much taper will depend on the depth and to depend on the material of the pattern. For example, if you are using a metal pattern, so obviously metal patterns are much smooth and the friction will be less. So therefore, the draft allowances can be less. Whereas if you are using a wooden pattern, then the draft allowances has to be more because surfaces of a wooden pattern is much more rough compared to that of a metal pattern. And therefore, that is also a parameter that you have to take into account, the pattern material. And of course, the depth. The more the depth, less will be the draft allowances that is required. So let's see that this is the table. This is again a figure. You can see these are perpendicular sides. This is not a good design of a pattern. This is the good design. So the draft suggested draft value for external and internal surface, you can see as depth increases, the draft angle decreases, and for wood it is much higher and for metal it is much lesser. Okay, the next is machining allowances or finishing allowances. Now we know sand casting does not give a very good surface finish and the dimensions are not proper. Now to bring it to required size and good surface finish, we require to machine the surface after the casting has been done. Now that is possible only when there is enough metal in the casting for us to remove and finish it and finish it to required size and improve the surface finish. So for that you require some extra metal, and for that to happen you have to make the pattern size slightly larger than the final casting or the final product. So the pattern should be more, size of the pattern should be larger than the final product so that the casting is larger. If the casting is larger than the final product, then we can machine and bring it to the size by removing the extra material. So that allowances that is provided is called the finishing allowance and machining allowance. Okay, one thing you should remember in machining allowance is that when you pour the molten metal in the casting, the molten metal will flow into the casting and the impurities that is there, impurities will always be there. No matter how much you try, there will be certain impurities like slag, which will float, which are lighter, which will float, and which will be there on the top surface of the casting. Therefore, the top surface of the casting or the top surface of the cope, an extra allowances is given, extra machining allowances is given, because there you have to remove certain extra material which are certified along with the metal. Those extra material is mainly composed of a mixture of the metal and the slag and the impurities. So that has to be removed. Therefore, you can see on the cope side, you give extra allowances. The next allowance is distortion allowance and camber allowance. The certain shapes, like U shape, when you make a mold cavity of this shape, see, when you certify, because of the certification rate and because of the shape, this arm tends to move out. Therefore, it is required for us to create a pattern like this. The mold should be like this, so when it stretches, it comes to the required shape. So such improvisation are called camber allowances or distortion allowances. You can see some more example of camber allowances and distortion allowance. Another allowances is called the wrapping allowances. Wrapping allowances is basically, see, when you remove the pattern from the cope or the drag, you wrap the sides wall of the flux. You gently hit it with a rammer, and so that the pattern moves. When the pattern moves, it becomes free, it becomes loose, and you can take it out easily. Otherwise, the pattern tends to stick to the moist side. Therefore, you wrap it slightly so that it moves in the mold and becomes loose, and you can take it out. So for that, see here, as you are wrapping it, the size becomes more. So therefore, you have to decrease the size of the pattern slightly. Normally 1 mm on each side, we decrease it to compensate for wrapping allowances. This is the only negative allowances. This is the only negative allowances. All other allowances are positive allowances. So with this, we have finished our discussions on the different types of allowances. Let us discuss certain problem here. Okay. Now this is a casting which has to be done. For that, I have to make a pattern, and I have to calculate the sinkage allowances, and the metal is plain carbon steel. From the table, we have seen the plain carbon steel for 600 mm length, the sinkage up to 600 mm, the sinkage allowances is 21 mm per meter or 0.01 mm per meter. Now, so this is 200 mm, so this is 200. That means the allowances will be 200 plus 200 into 0.021, that is 4.2. So 4.2 will be added to these dimensions, and we get this is 204.2. Likewise, the other dimensions, that is 150, will be 153.2, and this will be 100.2. Now there is a hole here. Now because there is a hole and it will shrink, therefore we will make the size of the hole slightly bigger, and it will shrink and come to its original size. So the dimension of the hole will be 80 plus 80 into 0.021, that is 81.7 mm. Now why I have highlighted it, because there is some confusion. Many authors have said that here it will be a negative allowance should be given here because of shrinkage. But I agree that it should have a positive allowance, so that when it sinks, it should come to this original dimension of around 80. Okay, now another part of the problem is that if in the previous example, if an aluminum pattern is used for casting, the aluminum pattern is made again by casting using a wooden pattern, which is called the master pattern. I repeat, this aluminum pattern from which you will be doing the mold, making the mold, is made by another casting process, and for that casting process, we have used a wooden pattern. Now we have to calculate the dimensions of the master pattern. Now for that, already you have calculated it. Okay, so from this you can calculate the add the allowances for wooden for aluminum on this. Otherwise, you can calculate directly like this. From the table, steel dimension is 600 mm. Up to 600 mm, the shrinkage allowance is 21 mm per minute. Per meter. For aluminum, the shrinkage allowance is given as 13 mm per meter. So you can calculate once you calculate these aluminum shrinkage, then you can add the steel shrinkage, or directly you can add and do it. It won't make much of a difference. So again, I have told you, casting is a hit and trial process. So this 1 or 2 mm this side and that side doesn't matter much. So for dimension of 200 mm, the allowances is 200 plus 200 into 0.034, and that will be the dimension will be 6.8. So it is given around 206.8. Sorry. Likewise, 5.1, 3.4, and 2.72, 82.72. Likewise, you can see this 0.1 mm difference is there. That difference doesn't make any issue. Okay, from in previous problem, what will be the pattern dimension if all the surface of the casting need to be machined? So machining allowance will be calculating. So for dimensions 200, the allowance is 200 plus 5.5 plus 5.5 is given here. For steel up to 51 to 500, it is 5.5 normal surface. Cope side, it is 7. So both sides will be giving machining allowance. So I am adding the machining allowance on both sides. So it is 211, 3 mm inside hole. So it is 150, sorry, 150, it is 3 mm surface. So 3 mm, it's 156. For dimension of 100, it is one side is 3 and other side is 6. 6 because top side. I'll tell you how. And this will be a negative allowance because the size has to be, diameter has to be less, so that you can machine and increase the diameter of the hole. So it will be below 100, below 150. So 3 on diametrically on both sides. So it will be 74 mm. I'll show you. So here 5.5 this side, 5.5 this side, 3 on this side, 3 on that side, and 3 on this side, and 6 on this side, because this side on top surface will be the slags which has to be removed. So therefore it is more. So I hope pattern making allowances is clear to you. In the next lecture, we'll be discussing about molding sand. In this lecture, if you have any doubts, please contact me through my email, or you can put it in the comment box and I'll try to get back to you. Thank you for watching this video.